Hello everyone. As future engineers, you will be creating products, systems and structures. Design is not just an art. It is a crucial component in successful creation of engineering systems, for their functionality or their user satisfaction or their aesthetic appeal. So in this video we are going to discuss more about the basic elements of the design and the principles of the design. Commonly there are 7 basic elements of a design. First we start with the simplest element, which is point, or we can call it as a mark. It is the smallest and most fundamental unit. In engineering perspective, points, usually we use points for finding out the coordinates, represent the coordinates, endpoints, or sometimes locations. Think of it as a datum point on a technical drawing, or think of it as a single pixel on a mobile screen or a computer screen, a single pixel. It is where everything begins. Next up is the n number of points will form a line. So the line will be having length and width, but it doesn't have any depth. Artists sometimes uses lines for edges, outlines, but for engineers, but for us, lines represents connections, boundaries, and sometimes it also represents the motion of a car, or if you want to represent any motion of a car or bike, we will represent it by showing the lines. So broadly, lines are again classified into 3 types, which are horizontal, vertical and diagonal lines. Horizontal lines usually suggest calmness and stability, like shown in the figure, and sometimes think of it as a water line of a stable ship. Next one is a vertical lines. Vertical lines suggest more potential and movement, which can sometimes represents columns or skyscrapers. Next one is the diagonal lines. Diagonal lines strongly suggest movements and give more feeling of vitality of a picture. So the direction of a line conveys the mood and stability of this picture. Next one is the shape. A shape is an area defined by a boundary, which can be having differences in value or in a color or in texture. Shapes are usually in 2 dimensions. They have height and they have also depth. Think of it geometric sections like circle, square, triangle. These and all comes from the shapes. Shapes are key analyzing forces and optimizing the surfaces. Next one is third 3 dimensions, which is form, which is having 3 dimensions. Forms describe volume and mass. These are the 3D aspects of objects that we take up the space and can viewed from in any angle. This is where most of our engineering work happens. For example, we are designing a bike, and we are designing a diesel engine, or we are designing a bridge component. This and all comes under forms only. Next one is the space. Space is the 3D volume that can be, sometimes it can be empty or it can be filled. As we have seen something in 3 dimensions, 3D printing also, we can suggest the system to be filled or to be hollow. In engineering, space management is most crucial. See, here you need to deal with the positive space or negative space. Let me tell you with one example. See, if you are designing a circuit board, which means there will be a negative space, you need to manage the negative space to prevent the short circuits. For example, if you are designing a public area, then you need to have empty spaces for flowing of people or flowing of any vehicles safely. Next one is the color. Most important thing is the color. Color in design involves 3 properties: hue, value and intensity. In engineering, color is functional. It conveys information. See, let us say you have a 3 wires, one color is red, another color is green. They represents the codes. Sometimes it can represents warning signs also. Value means it is darkness, how much dark it is there, or how much lightness is there, that represents the value. And intensity means, intensity is essential, we will see it as a contrast. In our mobile screen we will see no contrast, we can lower it or we can make it higher. That is what we call it as a intensity of a light. So these are the examples of colors. Next one is the final one is the texture. Texture refers to the surface quality. Sometimes it can be smooth, sometimes it can be sometimes it can be smooth and sometimes it can be rough. But in two-dimensional diagram, how can we represent a texture that is having roughness? How can we show it in the 2 dimension? This is where the texture comes into picture. So these are all the elements of the design. In next video we will see about principles of the design.